Now, are you ready for some really gross ones? Yeah. These are fun. Okay, first one up. We have the summation of n over n plus 1 to the n squared. Now, the thing I don't like about that is that exponent. And the root test would get rid of one of them, but not both of them. But I'm going to do the root test anyway to see what happens. So I need to look at the limit as n goes to infinity of n over n plus 1. This is raised to the n, so if I do the root test, I only have one n. This is an indeterminate form. We have 1 to the infinity. You're going to do L'Hopital's. You're going to see a lot of L'Hopital's, but I have to rewrite this first in terms of exponential so that I can get at it, because to just do L'Hopital's, you need 0 over 0 or infinity over infinity. If you've got 1 to the infinity or some other weird kind of exponential, you need to massage it and get so that you can actually apply L'Hopital's rule. So n goes to infinity. This becomes e to the natural log of all of that. So I've got the natural log of n over n plus 1 raised to the n. But remember, raising it to the n means I can bring it out front as a coefficient. So now what I need to do is figure out what happens to that exponent. So I'm going off on the side, sort of. And I have the natural log of n over n plus 1. That's going to go to 0. And if I put the n here, I'll have infinity times 0, also indeterminate but not L'Hopitalable. When you have 0 times infinity, you shove 1 to the bottom so that you can do L'Hopital. And you almost never, ever put the natural log on the bottom. Ooh, I got mail. So I have 1 over n on the bottom. So now we have 0 over 0, so I can L'Hopital it. The derivative of natural log of crap is 1 over crap, so I've got n plus 1 over n times the derivative. Oh, there's no cute way of doing the derivative. I'm just going to have to do quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And the derivative of the bottom is negative 1 over n squared. So let's clean this mess up a little bit so I can see what I got. This becomes a 1. This pops up here. So I have n plus 1 over n times n plus 1 squared. When this comes up, I have a negative n squared. So if I were to multiply all this out, the degree of the top is 3, the degree of the bottom is 3, the leading coefficient on top would be negative 1, the leading coefficient on bottom would be 1, so this limit is negative 1. So that means my exponent up here goes to negative 1. My limit is e to the negative 1, which is less than 1, which means this converges absolutely. Why am I spelling this all out? I don't know. One down. Don't know that. Cool. So this one kind of threw me for a loop. I'm like, how do I attack this one? It's kind of like n to the 1, but it's got this extra shit here, but that extra shit's going to 0. Is that going to be enough to make it go to 0 fast enough? Well, let's try the limit comparison test. Can't do the root rate. Well, there's no root to root here. It would be really nasty. And I could do a ratio test, but then I would but then I would have 1 over n plus 1. Oh, no. I'm going to do the limit comparison and hope. Well, let's see what happens. Comparison test. I think this is going to diverge. So I'm going to 1 plus 1 over n. I'm going to compare it with 1 over n. And this is the limit as n goes to infinity. So on top, I have an n, because this is going to flip. And on bottom, I have n to the 1 plus 1 over n, which simplifies. This is n to the 1, this is n to the 1 plus 1 over n. This gives me n to the negative 1 over n. And as n goes to infinity, I have infinity to the 0, another indeterminate form. So we are going to write this using e. So I have e to the natural log of n to the negative 1 over n, but I can write this up here. Now I don't even need to do L'Hopital's on this one. Wait a minute. Natural log of n over n. As n goes to infinity, I know natural log of n is really, really slow. I know this goes to 0. So this expression goes to e to the 0, which is 1. And since I'm doing the limit comparison test and not the ratio of the root test, that's actually cool. I divided by something that was diverging. I got a number between 0 and infinity, so I don't have to remember which one's which. So it's going to do the same thing as 1 over n, which means this guy diverges. Next. (37) was the summation as n goes from 1 to infinity of the nth root of 2 minus 1 to the nth. This actually probably should have gone in the other video because it's not that bad. I've got all this crap raised to the n. If I do the root test, I'm looking at the limit as n goes to infinity of the nth root of 2 minus 1. This goes to 0, which is less than, its root test is less than 1, so it's going to converge. Next on my list, this one concerned me because I saw that e on top. It's e to the 1 over n. What the hell is that? Over n squared. I wasn't sure what to do about that. So let's just try something. Let's try the limit comparison test. I think it might actually converge because I've got an n squared on bottom and this guy's going to 0. Or it's going to 1. So let's look at the limit comparison test and see what I get. And I'm going to pair it with 1 over n squared. So I've got e to the 1 over n squared all over 1 over n squared. And this is the limit as n goes to infinity. Do my flippy floppy simplify. And I have e to the 1 over n squared times n squared. Hoo-hoo, they cancel. As n goes to infinity, 1 over n goes to 0. E to the 0 is 1. Since we're doing the limit comparison test, that's cool. I divided by something that was converging, so this one converges. And since it's positive all the time, this converges absolutely if we want to make that distinction. Same thing here, converges absolutely. So your community, well, we got 3 more to do. We'll get through this. Okay. So this next one probably should have gone on the other video. It's not that hard, but it's here. Let's do it. 32. We have the summation of n factorial to the n over n to the 4n. Now notice I've got n factorial to the n, and I basically have n to the 4th to the n. The top's going to blow it away. This is going to diverge. Let's do the root test so you can see what I'm talking about. Root test. So if I take the nth root of this, I will have n factorial over n to the 4th. This is equal to infinity, which when you're doing the root test, this is greater than 1. This means this will, can't spell diverge. Now, This next one was a bit of a bear. Took me a couple times, a couple recordings, a couple of, oh no, that's not right, let's try it again. Summation, as n goes from 1, is it 1? That's probably 0, it's 2, to infinity, of 1 over the natural log of n raised to the natural log of n. That's just hideous. I am going to compare this, I'm going to compare it with 1 over n squared, because this is going to converge. Because I've worked it out a couple times, I know it converges. So looking at the limit, comparison test. I have the limit as n goes to infinity of 1 over the natural log of n raised to the natural log of n all over 1 over n squared. Simplifying it, flipping it the way I'm supposed to flip it, I get n squared over the natural log of n raised to the natural log of n. Now, I've got infinity over infinity. I don't want to take the derivative of this. It just gets nasty, and I end up getting another n on top, and it just goes back to where I started. So that didn't help me any. I'm going to try the E trick, because the E trick really does help. I just have to be patient. So I can rewrite this as e to the natural log of all that. N squared over the natural log of n raised to the natural log of n. And before I go off doing limits, actually I want to look at this top part and see what happens to it. Where does this go? Well, first I want to simplify it. I have the natural log of this over that, which means I can subtract. Let me just write that. Don't skip steps, Megan. Which means I have the natural log of the top, n squared, so the 2 goes to the front, minus the natural log of the second one, which is the natural log of n, raised to the natural log of n, which can come up front, because it's a power. Now, I notice I have the natural log of n here, the natural log of n here. I'm going to factor that out just so I can see a little better what's going on. This guy, natural log of n, goes to infinity. Natural log of n goes to infinity, and 2 minus infinity is negative infinity. So this is going to go to negative infinity. So going back here, I had e to all that crap. So I have e to the negative infinity. Ooh, that's really bad notation. Forgive me. Which is a 0. Now, since I'm doing the limit comparison test, and I got a 0 when I'm trying to prove convergence, that's okay. So this converges absolutely. One more, and we're done. I'm done. My husband will be happy. He's been yelling at me. Come down for dinner. Shut up. Last one, 38. Summation of the nth root of 2 minus 1. This one's going to diverge. I know, because I've already done it. I'm going to compare it with 1 over n using the limit comparison test. So I'm looking at the limit as n goes to infinity. This is 2 to the 1 over n, making taking the derivative in a minute easier, all over, I'm comparing it to 1 over n. So this is going to 0, this is going to 0. I'm not going to flip this, you'll see what I mean. Doing L'Hopital's rule, I get the limit 2 to the 1 over n. The derivative of 2 to the crap is 2 to the crap times natural log of 2 times the derivative of whatever the exponent was. And then 1 over n, get the same derivative. That's weird. How convenient. They cancel. As n goes to infinity, 1 over n goes to 0, and 2 to the 0, this pup goes to 1. So that means this limit is the natural log of 2. And since I divided by 1 over n and n diverges, and we got we didn't get 0 or infinity, we got something in the middle. This means this diverges. No, you will not see this one on a test. You won't see the previous one on a test. That other one might not be bad. Anyway, have a wonderful night, because I assume it's your evening for you too. And that's a good place to stop.